Hello guys, welcome back. Today I'm going to explain to you how thread works in Java. Thread itself is a very wide and complex topic. So we are only going to look at thread from a very high level point of view, and I will explain to you with an example how to create a simple thread. So let's understand how thread works in the first place. These days all the tasks that we are trying to perform, they are either complex in nature or there are multiple tasks involved to achieve one outcome. If we think about old days when CPU was just a single core and processing power was less, we have to do all tasks in a sequential manner. We have to wait for one task to be finished before we can start the next task. And once we have all tasks finished, then we can collate all the result and then achieve our desired output. Now with latest technology, we have multiple core, we have very high processing and computational power. Then how do we better make use of it? So multi-threading allows basically running multiple tasks in parallel. So what do I mean by that? So basically when you have tasks running in a separate threads, processor splits its processing power between threads and you can have all these tasks running in parallel. Now it is done more smartly than the way I'm explaining it, but just assume that the processor is now split into multiple threads and basically each task is running in parallel. Whenever one thread sleeps or it gives processor some sort of break, then processor will divert all that energy to run other tasks in parallel. So basically you can achieve multiple things in the same timeline. Now if the tasks are dependent on each other, thread also have a facility to either prioritize them or you can lock the thread before other thread finish execution. So all that complexity is there for you to use, but we are not going to get into that today. But yeah, thread basically allows user to run multiple tasks in parallel, and that's the topic we are trying to cover today. So let's look at it with an example. So as you can see on the screen, I have created a main class. So main class will be used for executing any task that we create. So to explain how thread works, I'm going to create two different tasks, which is essentially just classes in Java. And we will create an object of each task. We'll run it sequentially using single thread environment. And then we will try and execute the same task in a multi-threaded manner and you will see the difference. So let's create a couple of tasks first. So I'm going to create two classes, one called task1 and another one called task2. And what we want to achieve with these tasks is let's say user can pass some string data and then we can just keep printing that string in a for loop for let's say 500 times. So to achieve that, let's create a constructor and allow user to pass some data. So I'm going to create a variable called data and user will pass that string. We create a local variable which then holds that information. So whenever a user pass some information from the object, we can just store it locally and then we can use it. Now we need some sort of method that we can call and it will run and it will print our data in a loop. So let's create a public method which returns void, which is nothing, and we can call it run. You can call it whatever you like, but I'm calling it run for a very specific reason and I will come back to you in a minute. So once we create a run method, we want to create a for loop which then just prints our past data, let's say 500 times. Let's make it less than equal to, so it might be 501 time, but then it will sound about right. There you go. So now we have for loop and all we need to do is now system.out.println, which will then print our data and just so that we know how many for loop we are running, we can add for loop count in there as well. So once data is passed and someone calls run method, it will just run in the for loop and print these data with some count, right? Now, as a rule of thumb, whenever we have while loop or for loop, we should have some sort of sleep. So then processor gets enough time to process other things if it needs to. So I'm going to call sleep method. We don't have to specify which thread we are calling because the compiler knows that thread.sleep which thread it needs to sleep. Um, Now thread.sleep takes millisecond as an argument. So what we can do, we can hardcode some value, like let's say sleep 30 millisecond. But just to make it more interesting, let's create some random number. So I can use Java's inbuilt functionality called random class, and I can say give me the next integer, and it will give me next integer, which I'm saying please bound to 50. So what does that mean is it will create a random integer with boundary of 50. That means it will create integer only between 0 to 50, and that gets passed into thread.sleep function, which then gets used as a millisecond number to sleep. So it will have some millisecond between 0 to 50, and every time this for loop is executing, it will sleep from 0 to 50 millisecond. Now we need to handle it with try and catch, so let's call that. I'm going to try and catch outside for loop, so it exits if any exception happen, and for loop won't try and do that again. So there you go. So now we have a class with some basic task that just prints some information. We can copy that entire function into task2 as well, because we want both tasks to actually do the same thing for now. Now in your real life scenario, both tasks might be doing different things, but just so that you can understand the concept, I'm going to keep them both same. So there you go. Now we have two tasks, and let's see how they work. So to execute those tasks, let's create the class objects. So I'm going to call first object t1 and call the task. Now it's asking for some information, so I'm providing some string called Sam. Now let's create task2, which is using the class task2, and instead of Sam, let's call it Arpit. And by creating object, it doesn't run by itself, so we have to call the actual method that we want to run. So in task 1 it will be run method, and because task 2 is exactly identical, so task 2 also has a run method. So if we run these, so this is a single thread example, right? So when you run these, the both tasks will run in a sequence. So first the task 1 will finish its run method, which means it will print Sam plus some integer number, and it will go on till count hits 500, and then it will execute t2 run, and same thing, it will print Arpit with some integer number, and it will go on till 500 count. So let's see if our class works the way we expect. So if you watch the screen, you can see it's printing Sam 0 to 500, and then as soon as it finishes, it will print Arpit from 0 to 500. There you go, Sam is finished, and now we switch to Arpit. So what does this tell you? These pretty much is the simplest example of how to run two tasks in a sequential manner with single thread processor. But this is not efficient. We know our computer is much faster and it can actually run both tasks in parallel. But the way we have written our code, it has to run in sequential manner. So how do we make it multi-threaded? How do we create a thread and have them run in parallel? So let me show you the same example. How can you convert it into multi-thread example? So let me first comment these out. So We will keep it for our reference. And I'm gonna write multi-threaded code here. So we can use the same exact two tasks, and just with the minor change, it will become a class that can be used in a multi-threaded environment. So one thing you must do is implement Runnable. Now, if you don't know what implements means, either you can watch some of my interface tutorials or read about interfaces, just so that you can understand quickly. We are trying to implement a runnable interface. And what does that mean? That we have to make sure that our class abide by the law of what runnable interface is trying to implement. So one of the method Runnable enforces is called public void run. Now, just so that you can see it, I'm going to comment out my current method, and then it's showing compiler error. It's saying you have not implemented one of the method. Please implement it. So if I click on it, you can see that they provided us the method that we must implement, which is called public void run. Now we already have implemented that method, so I'm going to just delete this one for now and uncomment my code. Now, because we are overriding that method using our class, we must say override here, which is just one of the Java right way to do things. So compiler won't complain if you don't say override here, but it's always a good practice to say that, look, we are trying to override this run method using our class, so please execute our run method and not the one from Runnable or wherever else. And the same thing we need to do for task 2. So again, we say implements Runnable. And as soon as we do that, we must make sure that the method we have overridden, we specifically say that's override. So there you go. We pretty much converted our both class to implement Runnable. Now the reason why we must do that, and I'll come back to that in a minute. Um, so let's look at our original code. So in a main method, previously we used to create object of our task and then call the method that we needed to execute. Now when we want to run the same thing in a multi-threaded environment, we should create the object of thread first. So if you just type thread and call object t1, then create a new thread object. So we need to create basically two thread objects because we have two different tasks that we want to run in a two separate thread. Um, so as you can see, the constructor must have some sort of argument. So let's see what that argument type is. So as you can see, the very first option, it says we accept runnable as an object. So any object that has type runnable or it implements runnable. So we already have made our both task implement runnable interface. So we can safely say that both of our objects are runnable type. And that means we can now pass object of our tasks as an argument. And we will do the same thing what we did it previously. So task 1 will take same as an argument and task 2 will take repeat as an argument. So now you know why we implemented runnable on both tasks, because when we want to pass our class into thread object, it has to be a runnable type. So by implementing runnable on both of our tasks, we allowed that to be possible, right? And other difference is previously we used to call the class object and run the method that was actually being executed. But in a thread environment, we always call one method called start. And start method knows which interface you have applied. That means it also knows that it needs to execute run method in the background. So you don't need to worry about all that. The thread will look after that. All you have to remember is every time you want to start the thread, you just call thread object name dot start. And same for the task 2. we call t2.start. So as you can see from our original implementation, it's not too much different. The only difference is instead of direct object calling, we are creating a thread object first, and our object is being passed as an argument in the thread, and instead of calling the method name itself, we are calling start. So the way it's gonna do things now, because now both task is running in a separate thread, you will see that instead of having Sam printed first and then Arpit, it will now run in parallel. So you will see Sam and Arpit printed like one after each other. So let's see how it works. So there you go. As you can see, there are some SAMs and some Arpits. So whenever a processor gets some free time, it will process next thread, and that's why they are both running in parallel. And you can see that the 500 count is reaching very quickly, and it was much quicker, faster, and they both were running in parallel. So there you go. You just achieved your very first multi-threaded task example. Now, Thread has much more than that. So if you would like to know more, please keep watching my next upcoming tutorial. Don't forget to subscribe so you will be notified whenever I post new video. Thanks for watching, and happy Christmas, guys.